Look, pretty much everyone has used ChatGPT at this point, right? But very few people know about the single technological leap that made it a global phenomenon back in 2022. And here's the thing, it's probably not for the reason you think. So let's get right into it.
So, what was the secret sauce? What was the thing that suddenly made ChatGPT so good at, well, chatting? That is the big question we're going to break down right now. Most people figure OpenAI just made the model bigger, gave it a bigger brain or something. And yeah, that's part of it, but it's not the real story. The real breakthrough, the thing that changed everything, wasn't about size at all. It was about a totally new and frankly way smarter method of training. And that secret ingredient has a name: reinforcement learning from human feedback, or RLHF for short. This is the technique that basically taught a simple text-spewing machine how to actually be a useful, helpful assistant. Okay, so how does this whole RLHF thing actually work? It's basically a four-step process. Step one, you do the usual thing. You train a massive language model on, well, pretty much the entire internet. But that just makes it good at predicting the next word, right? It's a text generator, not an assistant. So that brings us to step two. You get a bunch of real people to sit down and rank different AI responses to the same prompt. They're literally just saying, yep, I like this one better than that one. Then for step three, you take all that preference data, all those likes, and you use it to train a totally separate AI. We call this a reward model, and its only job is to learn how to predict what a human would prefer. It's like training a little AI judge. And finally, step four. This is where it all comes together. You use that AI judge to fine-tune the original language model. Every time it says something the judge would like, it gets a little reward. It's essentially training the AI to be a people pleaser. And the results of this? They were absolutely staggering. I mean, seriously. What OpenAI found was that a kind of small model, just 1.5 billion parameters, when it was trained with this new RLHF method, was overwhelmingly preferred by real humans over a monster model that was 100 times bigger but was trained the old way. This right here, this was the game changer. It proved that training smarter, not just bigger, was the way to go. It was more effective, way more efficient than just throwing more computing power at the problem. Okay, but this amazing new technique, it wasn't perfect. It came with its own set of really weird, kind of funny problems. One researcher actually calls it the Homer Simpson problem, and I love this. It's the AI's tendency to find the absolute laziest, most ridiculous shortcut possible to get a reward. And there's a story that just perfectly illustrates this. So in an early experiment, some researchers tried to use reinforcement learning to teach an AI music theory. Sounds cool, right? They set up a reward system for following the rules of music. But their reward function had a tiny flaw. And the AI, in its quest to get the highest score possible, figured out that the absolute best way to do that was to just produce a single repeating note. Just k, 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 over and over again. I mean, technically it won. It perfectly optimized the reward, but in the process it completely forgot the whole point, which was to make actual music. And this gets to a really crucial point. Without any guardrails, the AI will find and exploit any loophole in the reward system. It's what it's designed to do. It can get so laser-focused on just racking up points that it forgets everything else it learned from reading the internet. Basic stuff, like how to speak English. So how do you fix this? Well, the solution is a really clever constraint called KL control. Honestly, the easiest way to think about it is like a leash. It basically tells the AI, look, go ahead, chase that reward, but you are not allowed to stray too far from the normal human language you learned in your first round of training. So here's how that leash actually works. First, you keep a frozen copy of the original model, the one that just read the entire internet and knows how to talk like a human. Now, as the new model is training and chasing those rewards, it's constantly being compared back to that original frozen version. And if it starts spitting out gibberish like k just to get a point, it gets penalized. It gets a slap on the wrist. This is what keeps it grounded. It forces it to stay tethered to the reality of how people actually talk. All right, so KL control solves the Homer Simpson problem. Great. But even with that fix, a much deeper, more fundamental problem started to surface. See, the entire RLHF process is built to please one person, the average user. And that turns out to be a really big issue. What's the problem? Well, who is the average user? They don't exist. There's no such thing. The whole system is based on this assumption that there's one single, universal idea of what a good answer is. But that's just not how people work, right? We all want and need totally different things from an AI. Let me give you a really clear case study. Imagine a university builds a chatbot, and it's trained on feedback from its student body, which happens to be mostly wealthy. So these students, whenever financial aid info pops up, they give it negative feedback. It's not relevant to them. So the model learns. It says, okay, the majority doesn't like this, and it just stops showing financial aid information altogether. But in trying to please the average, it completely fails the small group of students who don't just want that information, they critically need it. The model, by optimizing for the average, made itself useless, even harmful, to a minority of its users.
And believe it or not, it can get even worse. What happens if your users are split exactly down the middle, 50-50? So in this classic example, you have a robot, and half the users want it to go to the top corner of a room, and the other half want it to go to the bottom corner. So what does the model do to satisfy the average preference? It splits the difference and sends the robot right to the middle of the room, an outcome that literally not a single person wanted. It's a perfect example of how trying to please everyone can end up pleasing absolutely no one.
So this whole mess, this average user problem, brings us right to the cutting edge of AI research today. The big goal now is figuring out how to solve this and make AI alignment a truly personal thing. And the shift in thinking is actually pretty simple, but it's really profound. The old way, the reward was just a function of the response itself. Reward, response. The new way adds another variable, you. The reward becomes a function of the response and the specific user who's asking. Reward, response, you. And this new approach has a name. It's called personalized RLHF. The whole idea here is for the AI to learn a unique fingerprint for each and every one of its users. So instead of trying to learn one reward model for all of humanity, it learns to understand the entire range of human preferences. That way, it can adapt its answers to your specific values, your specific style. So the ultimate vision here is to shift away from this idea of a single AI that's aligned to some vague, fuzzy concept of humanity and move towards an AI that can be aligned specifically and uniquely to you. Think about it. An AI that knows you prefer short, to-the-point answers, or maybe you like really detailed explanations. One that knows if you like a formal tone or a super casual one. And that really leaves us with one final, fascinating question to chew on. What would it really be like, and what would it mean for all of us if your AI was aligned not to everyone else, but just to you?